Okay, folks, we're back. Just to give you a little preview of what to prepare for this lesson. The notes, where we left off, we only put number 1, 2, and 3 under basic concepts. So number 2 are the Greek prefixes. And number 3 is common conversion factors. So I've got some stuff on the board that I'll fill in for that. So you kind of want to maybe just write those 2 headings down. I'm not sure how much good it's going to do you. You're also going to want a calculator out, ready to go, because we're just going to do a bunch of problems today to get you ready for the quiz and just ready to get to do the homework. Okay, so I think I can come out in front of the camera. Also, one thing I learned is stand a little closer to the board so the top of my head isn't getting cut off. So I'll figure some of this out as we go along. It'll work okay. All right. So not a ton of notes today. We're going to jump in and start doing the practice unit conversion problems on the PowerPoint slides. And one thing we're not really going over explicitly is scientific notation, because I think we kind of are doing scientific notation already. But anyway, so the Greek prefixes, I told you before, or mentioned before, that you want to memorize those ones. And I'm not going to put them all up here. I'm just going to do some examples and just comment on them, because maybe hearing about them just in real time from your instructor will help reinforce what's in the book. And if you already know this stuff, just bear with me. So we use the Greek prefixes to take the base unit, or any unit, and scale it up or down depending on what we're measuring. So we already know 1 kilo, and I'm using mass here, not meters, mass as my example, and I'll use grams as my example. We know a kilogram is actually the base unit for mass, which is kind of unusual. And 1 kilogram is 10 to the 3rd, or 1,000. grams. And remember, 10 to the 3rd is you take, that's the same as 1 times 10 to the 3rd, so you take the decimal point and move it 3 to the right. It's negative 3rd, it's 1, 10 to the negative 3, move it 3 to the left, so 0.001, it's negative 3. Okay, we got to sort all that out. And that's, I don't have a great way of explaining to everybody how to do that. People have different ways of understanding Greek prefixes. Just make sure you get the answers right. Okay, so 1 kilogram is 10 to the 3rd grams. If you solve this equation and you bring the 10 to the 3rd over to this side, it's 1 over 10 to the 3rd, which is 10 to the negative 3rd. So 10 to the negative 3rd kilogram is 1 gram, or 0.001 kilogram equals 1 gram. That's kind of an awkward way of doing it in my view, but make sure you understand how the Greek prefixes work. I think it's easiest to go from the unit with the Greek prefix to the unit without the Greek prefix. So kilogram is 10 to the negative 3rd grams. There are some exceptions, just because of my past and I learned it this way. Kilogram, we use some of it. That's almost an engineering level unit. We don't do kilograms a whole lot in science because that's a lot of stuff, and that's inherently unsafe. There is a unit that goes to a bigger level called mega, which is 10 to the 6, capital M. Unfortunately, that's another unit we're going to use in science class, in chemistry class, called molarity, the number of moles of a substance per liter, but we're not there yet. So, and that goes 10 to the 6 grams. You also know that centimeters, like there's 100 centimeters in a meter. Okay, well, that's fine. Well, there's 100 centigrams in a gram. Well, there's 100 centiliters in a liter. So 1 centigram is actually 10 to the negative 2 grams. So centi means 10 to the negative 2, or the other way you can think about this is 100 centigrams or 100 centimeters or whatever is a gram. So these are taking things and taking the unit that you're dealing with and making them smaller. So it's really important to know. I'm not going to necessarily write all of these up here. So 1 milligram, very common unit in science, health professions, everywhere. Milligram is 10 to the negative 3rd grams, so there are 1,000 milligrams every 1 gram. Is another way of doing it. A microgram, also quite common actually, especially when you're talking about medicine, is 10 to the negative 6 grams. So this is a 1,000th of a gram. This is a millionth of a gram. And then the last one I'm going to do, let's see, that's microgram, and I think the next one, we go in steps of 3, is a nanogram. Really difficult to measure at that level. Usually we're talking about nanometers or nanoseconds for really small distances and really quick times. I'm not going to put them all up here. So there's also pico and femto, which pretty much apply only to particle physics, I think. It's really tough to get to that level. So pico and femto are, let's see, was it 10 to the negative 12th for pico and 10 to the negative 15th for femto. So just make sure you know these. This will be part of Friday's quiz. Fine. So those you want to know, but we're going to do problems with those because I don't think it makes a whole lot of sense thinking about them in the abstract. And I want to leave some space here. Okay, so those are the Greek prefixes. Wow, that doesn't erase very well. That's fine. Then we have conversion factors. Now, I will give you most of these on a quiz, so you don't have to memorize every single conversion factor. There's some that you should know, okay? You should know that there's 12 inches in a foot. Okay, that's good to know. 3 feet in a yard. I think you should know that. That's pretty common. Those are like British units. Those are the old English style units that we still use in the United States. Used all over the world, but more in common everyday language, not in a scientific laboratory environment. We still have to be able to deal with them. So some other ones, if it's not the basic ones like that, okay, 60 seconds in a minute, 60 minutes in an hour. Okay, those are things you should know. 365 days in a year. So those are elementary level, if you will, unit conversions that you should know. And I will, whenever I give you a quiz or a test, I'm going to write these across the top, also forgetting to stay close to the board. I just want to give you some other ones here that are useful. And maybe you know them already. And mostly what we're doing here is we're going from the English set of units, or British units, to the SI, Système International, it's French. So international system of units. Not all of them. I'm just going to kind of put random ones up here because it's not hugely important. I find measurement fascinating, by the way. So a pretty common one for mass is 1 pound. So LV, pound. 1 pound is 453.6 grams. That's a useful conversion. A kilogram is about 2.205 pounds. That's also pretty useful. Any of you have lifted weights in the gym, sometimes you see pounds and kilograms are the same on the weights, the big metal plates. It's fine. Another useful one, I just put this one because it's kind of fun. Another one, these are the British SI ones. My wife and I went to Scotland a few years ago, and they measure body weight typically in something called stone. How many stone do you weigh? We're not going to do that in class. That'll do a problem. But a stone is about 14 pounds, so you don't have to be many stones to weigh a lot. Length. Well, you all know that a meter is a little bit more than a yard. So if you're going to make a conversion factor, 1 meter is going to be slightly more than 1 yard. It's actually 1.094 yards to make those two equivalent. A mile, MI is mile, is 1.609 kilometers. Again, these are the British and English ones. So a mile is, okay, and those of you that are runners or distance athletes probably have a sense for kilometers and miles. If you've ever done a long bike ride, a metric century is about 65 miles. And then 1 inch is 2.54 centimeters. I would memorize that one. I'll give that to you, but that comes up so often. And then some other units that are useful, okay. 12 inches equals 1 foot. You should know that. Oh, this this is an old-fashioned one. I don't see this one very often, except maybe in biochemistry. I'm going to put one of these on the quiz. It's an A with a little circle above it. It's actually Swedish. It's called an angstrom in the United States, or an ångstrom if you're in Sweden or Europe. An ångstrom is used to measure really small things like biological molecules. And an ångstrom is 1 times 10 to the minus 10th meters. Or just 10 to the minus 10th meters. The 1 is just a placeholder. Another useful one is 5,280 feet is equivalent to a mile. That's just a useful one to know. How many feet are in a mile? 5,280 feet are in a mile. Great. That's the most. Volume, gallon is 3.785 liters. You can see how much I memorize these ones. I have to look at my answers. And if we're talking about liquids or fluids, a fluid ounce, like a soda, so a fluid ounce, sorry, it's FLOZ, it doesn't look very good, is the same thing as 29.57 cubic centimeters. And what's the same thing as a cubic centimeter? A milliliter. Yeah, we already got, so a cubic centimeter is a milliliter. That's a good one to know. This one comes up sometimes. A liter is actually the same thing as a cubic decimeter, which we didn't do deci up here. 1 decigram is 10 to the minus 1st grams. It's not a very useful unit in my view. So I really should have put that one, I think, there, but that's okay. So a liter, 1 liter is a cubic decimeter. We already did the cubic centimeters and no. And then 4 quarts is 1 gallon. That's almost exclusively useful in the United States and England. So 4 quarts in a gallon, that's, you might know that one. We don't do a lot of conversion factors for time because everybody uses seconds and goes from there. So there really aren't any. But something that's useful, 60 seconds in a minute, 60 minutes in an hour, 60 times 60 is 3,600, so 3,600 seconds in an hour. That one comes up a lot. So 1 hour, sorry, running out of space, is 3,600 seconds. And some ones I'm going to explain later. I'm going to run out of space here. Temperature, or base unit, is Kelvin. Pressure, we don't have a base unit because it's a combination of all kinds of other stuff, but there's some useful conversions to know. Sorry, this is going to, so Kelvin equals whatever the degrees Celsius is, like so 20 degrees Celsius plus 273.15. I'm just showing you that now. We're going to do more of that later, and I'll show you where it comes from. And pressure, I showed you millimeters of mercury. 760 millimeters of mercury is equal to 1 atmosphere. It's defined to be standard pressure. 1 atmosphere is 760 millimeters of mercury, and technically that's at sea level. Because if you go higher in the atmosphere, you get less atmospheric pressure, because there's less atmosphere. Okay. I'm going to leave all that there, and let's do some problems, because I don't really think we need to do more notes. Okay, so I'm switching over to the practice problems, where it says practice unit conversion problems and use scientific notation if appropriate. What does that mean? That means if you have a bunch of zeros, like 0.000000 blah, use scientific notation. If your answer is 5 gazillion to the decimal point, put it in scientific notation. And we haven't done significant figures yet, so we'll get to that later. I'm not going to worry about significant figures. I'll informally introduce them now. And let's just do a few of these. I'm not going to do all these from the notes, but let's just get started. And I don't have the answers. I don't have these answers written out, so the first one is convert my mass, which I haven't weighed myself in a while. I don't think I put on the COVID-15. but 225.7 pounds into kilograms and stones. Okay, so, all right, so 225.7 pounds. And we want to do, this is actually two problems, kilograms and stones. Okay, well, if you're given the conversion factors, great. And what I would do is look for your easiest way. So this goes to pounds to kilograms directly, that's awesome. You can do that. I never remember this one, so you can do this problem the same way. I remember grams the best. I always remember the first one, so I know, oh, by the way, so how do you do problems? You can work with me here. So basically, you start with the number you're given, and sometimes it would be a compound unit, like miles per hour, or grams per liter, or moles per liter, but this is not a compound unit, it's just pounds. And then what we're doing is multiplying by a series of fractions. And if you need help with the math, you see me. Most of you, I think, probably have seen this before. Some people do this fence posts method, where it's a series of fence. I don't care what method you use. I just basically look for a conversion factor that removes pounds and gives me something else. So let me just show you, I'm probably talking too much. So we know that a pound is 453.6 grams. I'm making this one slightly more complicated than it needs to be. I know that 1 pound is 453.6 grams. Always write the units. Always, always, always. Now, why do we do it this way? Okay, so if we have 225.7 pounds, that's going to be a whole boatload of grams. That's going to be a lot of grams, because 1 pound is 453.6 grams. So if you think about it this way, this will prevent you from doing something dumb like this. Well, I think it's dumb. 1 gram is 453.6 pounds. That relationship is not true. The numerator and the denominator have to be equivalent to one another. This is 1 gram, no, that's wrong. So make sure you understand that you put the relationship there so it does two things. That the numerator and denominator are equivalent, and that the units that you start with are canceled by the denominator of the conversion factor. So we cancel the pounds, numerator, denominator, and we're left with grams. And now we can go to kilograms. Because we know that 1 kilogram is 1,000 grams. Or you could write it 1 kilogram, I'm going to have to erase a lot of this, is 10 to the 3rd grams, or you could write it 10 to the minus 3rd kilograms is 1 gram. All three of those should get you the same answer. All right, and go ahead and solve that. So on your calculator, you're taking 225.7 multiplied by 453.6 multiplied by 1 dividing by 1,000 times. So on your calculator, you can just do this times this divided by this and skip all the ones. And I forgot to get my calculator out, so I've got to do that. Our stockroom guy bought us these, so nobody ever steals them. So 225.7 times 453.6 divided by 1,000, and I get a whole lot of numbers. I'm going to go into this later. Conversion factors do not affect how you write the final answer. This is called significant figures. This is all multiplication and division. I'm getting a little ahead of myself here. This has 4 significant figures. All those are non-zero digits. So we're going to write our answer with 4 significant digits, not decimal places. So I'm going to write this answer, and I actually have to round it, as 102.4 kilograms. So my body weight is about 102.4 kilograms, which is pretty sizable. Now, if you did this the quick way, which is more efficient, and you took pounds and you divided by, let's see, 1 kilogram is 2.205 pounds, you should also get this answer. So if you look at it, well, why did you make it so complicated? Well, I didn't have to, I just wanted to make a point. If you can do a complicated problem, the easy ones are, well, easy. All right, I'm taking up too much space here. Oh, I didn't do the second part, did I? Convert kilograms into stones. So what would I do? I would take, well, I would take my body mass and I would divide it by 14, wouldn't I? That's easy, that's a 1. So I would do 14 pounds down here is 1 stone up here. Do I need to do that? I don't think I need to do that. So 225.7 divided by 14. Okay, so I'm about 16.12 stone, which is how they would say it, I think. All right, fine. If you know what you're doing, go ahead and set up number 2. So we're going yards into centimeters. .078 yards. 0.078 yards. Oh, by the way, so preview of coming attractions. The zeros, what I call leading zeros, are not significant. Cool. So I don't have to worry about those. So this has 2 significant figures. So we're going to write 2 significant figures in our answer. So yards into centimeters. I don't think we have a way of doing that directly. I think a good way to do it is go to the unit without the Greek prefixes first. So go to meters first. If you get to meters, and centimeters is easy. So just find something that gets you to meters. So we can go yards to, oh, this is actually pretty easy. 1.094 yards is equal to a meter. So 1.094 yards is 1 meter. Okay. And then meters into centimeters. We want to go meters, cancel there. And we want to be left with centimeters. So what's the relationship? Well, we could do 1 centimeter is 10 to the negative 2 meters. That's fine. Or we could do 10 to the, yeah, we could do it that way. The way I always remember centimeters is that from a meter stick, just from school. 100 centimeters is equal to a meter. That's fine. It doesn't matter what way you do it. The answer should be the same. I want to show you a long way, just to show the point here. 0.078 yards. I know that 1 yard is equal to 3 feet. I'm just using things I remember. I know that 1 foot equals 12 inches. And I know that there are 2.54 inches in every centimeter. So for me, this is one more step, but it just illustrates how this works. So yards into feet, feet into inches, inches into centimeters, and hopefully I set that up right. So yards cancel, feet cancel, inches cancel, we're left with centimeters. Okay. And did I do the relationships right? 3 feet in a yard, that's right. 12 inches in a foot, and 1 centimeter is 2.5 inches. That's wrong. That's wrong. I did that wrong. That's not a true relationship. 1 centimeter is not 2.54 inches. It's the other way around. 1 inch is 2.54 centimeters. So that's sloppy. I didn't intend to do that. I make mistakes. So 1 inch is 2.54 centimeters. This is fine. Either way gives you the answer. The one thing I don't like about this method, well, first off, it's longer. Also, it might give you the false impression that conversion factors are always something over 1, something over 1, and something over 1, which is not true. You just, the 1 goes somewhere. It's always not always here. Now, this should give you the same answer. So go ahead and crank that out. I don't think I'm going to do, well, I guess I'll do this one. Okay. I'll just crank it out here real quick. So 0.078 divided by 1.094 100. .1, two significant figures. Centimeters, is that right? 0.078 divided by 1.094. Is that times 100? Yeah. Okay. And you should get the same answer for both of those. And okay, go ahead and set up number 3. I think we'll do number 3 and number 4 here with this video, and then maybe cycle back and do some of the other ones. I'm not sure we're going to do all of these. We never do a regular class anyway, but this video is getting too long. So, number 3 is what? 0.62 miles into nanometers. Wow, what a dumb problem. Nobody would ever do that. So, 0.62 miles, somewhere down here, we're going to get nanometers with 2 sig figs. Miles into nanometers. Oh, actually it's not that hard, because I give you this one. So you would take that 0.62 multiplied by 1.609 kilometers, go from kilometers to meters, go to the unit without the prefix, as your bridge, if you will. Then you would go meters into nanometers. I was going to make this really, really complicated and go miles into feet and then do that whole thing there. I'm going to skip that. So you could do this one like in 8 steps, or you could do it in fewer. Let's do the fewer one for this one. So 1 mile, let's make sure I get it right this time. 1 mile is 1.609 kilometers. And we know that 1 kilometer is 10 to the 3rd meters, or a kilometer is 1,000 meters. If you want to write 1,000 instead of 10 to the 3rd. And then we know, now we got to get the nano part right. We know that, now how do you want to do this? So I know that 1 nanometers, again, I think it's easiest to, when you're using the prefixes, especially the ones for these small ones, I just find it easier. 1 nanometer is 10 to the negative 9th meters. Cancel, 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 cancel. Relationships are correct. Okay. Good. Now the trick is, on this one, make sure in your calculator that the 10 to the negative 9th is put in the denominator. So the math here is 0.62 times 1.609 times 1,000, that answer, divided by 10 to the negative 9th. If you're a little slick with your units, 10 to the 3rd in the numerator divided by 10 to the minus 9th in the denominator is actually going to be 10 to the positive 12th. You take the exponents and you, in this case you subtract them. So 3 minus a minus 9, wow, which is positive. Okay, you don't have to do that. But if you understand your exponential notation, it actually makes this problem go a little bit faster. So 0.62 times, my calculator is not one of the graphing ones, we can do it all with one line, times 1.609 times 1,000, I'm just doing equals as I go, divided by 1 exponential 9 negative. Okay, I got a huge number. Does that make sense? Well, yeah. Because a nanometer is infinitesimally small, well, it's super small. And 0.62 miles is a little more than half a mile. So you're going to have a whole bunch of those. 2 sig figs, and scientific notation is definitely useful here. And, oh, this one's weird. Yeah, this one's going to be weird. So I've got to round this one up. So this, I came out with 9.9758 times 10 to the 11th. That's just my calculator gave me. But with 2 sig figs, because I'll show you this later. How do I do that? Well, I'd have to round that up, I'd have to round that up. This is actually going to end up being 1.0 times 10 to the 12th with 2 sig figs. I'm going to get to that later. That one's a little strange. Make sure you just do the math. So this one's going to be 1.0 times 10 to the 12th nanometers. I'm going to double check this. 0.62 times 1.609 times 1,000 divided by 1 exponential 9 negative. Okay. Yeah, I'm pretty sure that's right. You can always shoot me a message if I didn't get that right. All right, so start number 4. Okay. Number 4 is square millimeters. So you've got an area. So you've got square millimeters and you want to go to square feet. I'm not going to do the second part there. So, okay, so the hint here is when you have a unit that's square or cubed, well, you're just going to put a square or a cube on the conversion factor. That's how you do these problems. Okay, so start working on that one. I'm going to see if I can clean these boards. I'm not sure I can with the paper towels that I have. And we'll set this one up and we'll see where we are. So set that one up, start working on it. Let me see if I can get some space here. And I guess that'll work. It's going to be messy, but yeah, who cares? And this is where we'll end this one. I'm not going to get sig figs today. Or on this lecture. Alright, sorry about that. This is super messy. I'm just going to do it here now. And where'd I put my marker? Oh, there it is. So the area of a telescope is 7,903. 7,903 square millimeters. So that's actually a pretty small lens for a telescope. I think we pulled this one out of the book. And we want to go to square feet. Okay, so millimeters into feet. All right, we've got some options here. If you do something different, that's fine. Go for it. We should get the same answer. You know another one that I know that I use all the time for length? I didn't put it up here. It's useful. This skips that thing where I told you to go to the unit without the prefix and then go to the unit, the new prefix. You can do that. You can go millimeters to meters. That's fine. You can put 1 millimeter, so it'd be 1 millimeter here is 10 to the negative 3rd meters here, and square it. You can do that. You can do that. There's no problem. But millimeters and centimeters are so common. We know that 10 millimeters is 1 centimeter. We just look at a ruler. It's not that hard. This is elementary school stuff. This makes it a little bit faster. But do it the other way if you want to. See if you get the same answer. So we're going to end up dividing 7,903 divided by 100. A very common mistake students make is when they have the square down here, they square the unit but not the number. Another way of writing this is that a squared centimeter is 100 square millimeters. You can actually do the math and set it up without this thing on here if you want to. I think it's faster because your calculator can handle that. So this will be 7,903 divided by 10 raised to the 2nd power, or 100, when you get it to your calculator. Okay, so we also know that there's now, hopefully I get it right this time, 2.54 centimeters in an inch. But we have to square it, so we have to square 2.54. That ends up being like 16 something or other. I forget what it is. And you can do that if you want to. If you want to take 1 inch squared is 2.54 square, centimeters squared, but that's fine, you can do that. And then we know that there are 12 inches in every foot. So we're going to have to square the 12, which is 144. I think we have to, so 10 millimeters is a centimeter squared, 2.54 centimeters in an inch squared, 12 inches in a foot squared. Okay, so that math should be right. Oh, by the way, this is one of your homework problems. So let's try it. So I'm gonna take this divided by 100. Okay, so, well, and 7903 divided by 100 is going to be 79.03. Just move the decimal. So I'm going to start with 79.03. So 79.03 divided by 2.54, we're squared on this thing. Okay, oh, it's that 2.54 squared is not that. That's 2.54 cubed, sorry. 2.54 squared is something else. I was making a mistake. And then divided by 144. So I came out with 0.085067184. Jeez Louise. Okay. This is 4 significant figures. The 0 here is significant. We'll get to the rules later. So I need to report my answer to 4 significant figures. I'm going to put this in scientific notation. This is going to be 8.507. I have to round that. 8.1 times 10 to the negative 2 square feet. Hopefully I did that right. If I make a mistake, you can always let me know. Okay, so the sig figs are right. None of these affect the significant figures. These are all considered to be exact values, not measured values. So I'm going to try this one more time. 7903 divided by 100 divided by 144, doesn't matter the order you do it in, then divided by 2.54 squared. Yeah, I got the same answer. Okay. So that's it in feet, and the second one I'm going to let you do is you have a conversion factor, 135 square millimeters in every 40. So that one's actually a pretty straightforward problem. Just starting from millimeters squared, converted into seconds by using the technology, the tech's rate of working. Okay, so I think that's it for this video. It's kind of been long, so we'll leave it go there. And on Friday's quiz, we're going to have significant figures, which I haven't quite done formally yet, and then these kinds of problems. So be prepared to do that. Right. Good work.